Hey, y'all, let's cover lesson 28. This is Introduction to Square Roots. So you're going to recall that x squared is x times x. All right. When there's nothing there, we assume there's a 1 here. So 1 plus 1 is 2. So the number x squared is called the square of the number x. We're going to list the first 15 squares. So 0 squared, 1 squared, 2 squared, 3, 4, 5, 6, 7, 8, 9, 10. I'll come down here and go 11, 12, 13, 14, and then we'll just go to 15. Okay. 0 squared is 0 times 0, which is 0. 1 squared. Oh, so sorry. Okay, sorry about that. I've muted my phone. I haven't finished this. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, 25. 6 squared is 6 times 6, 36. 7 squared is 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9 is 81. 10 squared, 10 times 10 is 100. 11 squared, 11 times 11 is 121. 12 squared, 12 times 12 is 144. 13 squared, 13 times 13 is 169. 14 squared, 14 times 14 is 196. I remember that because 169, 196, they just flip. And then 15 squared is 15 times 15, 225. All right, we're going to be using some of these numbers as we work through this. Can a square be negative? No, a square cannot be negative. The question is why or why not? The answer is no, cannot be negative. Can't be negative. And then why or why not? Well, here's proof. If you put in -3 and you square it, remember it's got to have parentheses, then that is -3 times -3, and that's going to be a +9. So a negative times a negative, negative times a negative cannot be negative. Cannot be a negative. All right, that's the equal sign that means no, cannot be a negative. So no. Negative times a negative have to be a positive. Negative times a negative have to equal a positive. All right. So if a squared is equal to b, then a is called the square root of the number b. Okay. So for that, that means when we take the square root of 49, that means that something times something is 49. And that something is 7 times 7, 7 squared is 49. So that's one of the roots. 7 is one of the roots. Here's the other thing. -7 times -7 is 49. So -7 is another one of the roots. All right. It's not the square root of 49, but is a square root. It is one of the roots. I'll explain more here in a minute. Find the square roots of 256. Well, what times what is 256? 16 times 16 is 256. Also, -16 times -16 is 256. So 16 and -16 are the roots, square roots of 256. Okay, let's go to find the square root of 196. And up here, I already did 196 is 14 squared. So we know that 14 times 14 is 196, but also -14 times -14 is 196. So the square roots are 14 and -14. 625. 25 times 25 is 625, but also -25 times -25 is 625. Find the square roots of 0. So the only thing this could be, and there's only one of them, is 0 times 0 is 0. That's it. Find the square roots of negative 25. Well, can't be 5 times 5. What about negative 5 squared, which is negative 5 times negative 5? Well, that's negative times a negative is a positive 25. So there are none. Does not exist. So when you're doing mom, you're going to use D and E. Does not exist. Or you could say, for me, none, does not exist, whatever you want to say. There are none. All right, because negative 3 squared is equal to 9 and 3 squared equals to 9, both negative 3 and 3 are square roots of 9. Special notation called radical notation. Not like radical dude, it's just radical notation is what the square root is represented, is used to request these square roots. The radical notation, this little guy right here, is pronounced the non-negative square root of 9. It calls it the non-negative square root of 9. Square root of 9 is equal to, and this would be 3. Non-negative means that it's either a 0 or positive. Because remember, zeros are non-negative. The radical notation negative square root of 9 is pronounced the negative square root of 9, calls the negative square root of 9 like this, and that's equal to, well, it's a negative, and then the square root of 9 is 3. So that's the answer for that. All right. In the expression square root of 9, the symbol, the one that you see here, is called a radical. I will either call it a radical or a square root. And the number within the radical is, in this case, the 9. It's called the radicand. Not the radicant, it's the radicand. Sorry, I need to spell too. Radicand. All right, simplify the square root of 121. So the square root of 121 is just 11. It's not 11 and negative 11. Whenever I ask you for the square roots of a number, that's different. This is just giving you a problem. So we are solving this, we're simplifying we're simplifying this expression. And the square root of 121 is just 11. It has to be a positive answer. For B, we've got the negative of square root of 625. Well, our answer has to be a negative, and then the square root of 625 is 25. C is the square root of 0. Square root of 0 is just 0. Simplify negative square root of 125. Negative square root of 25 is going to be a negative, and the square root of 25 is just 5. All right. Simplify the square root of negative 25. There are none. So D and E, if you're doing mom, or even for me, I do not mind it as well. Order of operations. So evaluating square roots in the order of operations happens in the same step as exponents. And we're going to simplify negative 3 square root of 9 plus 12 square root of 4. So negative 3, I'm just going to rewrite it real quick, plus 12 square root of 4. So it's negative 3 times the square root of 9. The square root of 9 is 3. Plus 12 times the square root of 4, and the square root of 4 is 2. Negative 3 times 3 is negative 9. 12 times 2 is 24. All right, calculator. Negative 9 plus 24 is 15. All right, let's use our calculators for the rest of this, just to start getting comfortable with it. So we've got negative 2. I'm going to rewrite this real quick. Minus 2 times, what is the square root of 36? To find that on your calculator, it's second. Mine is, it needs to come out looking like this. Depends on the type of calculator you have. You need to come up with the square root. And then I'm going to put in 36 and equals, and that is 6. Order of operations, the next step is to go negative 2 times 6. That's negative 12. I'm going to bring my negative 2 down. Now negative 2 minus 12 is negative 14. Okay, right there. Square root of 9 plus 16. Here you need to be very careful. A lot of students try to break it down and make it look like this. It is not the same thing. This, you have to do what's underneath the radical first. So 9 plus 16 is the square root of 25. Square root of 25 is 5. That is very different from over here. The square root of 9 is 3, plus the square root of 16, which is 4. 3 plus 4 is 7. Not the same answers. Please do not think that this means this. It does not. Simplify the square root of 4 over 9. Okay, in this case, these had addition. We cannot separate them. If these were multiplication, we could have separated them. Okay, but it's not, it's addition, so you cannot separate the addition like that. Here, division, we can go, oh, square root of 4 over the square root of 9, just like we could with multiplication. Square root of 4 is 2. Square root of 9 is 3. Let me just 1 moment, please. Sorry, I felt like I taught this before. It feels like I just did yesterday. Okay, so now we've got negative square root of 0.49. So our answer is going to be negative, and I just need to take that square root of 0.49, and I get 0.7. Okay. Estimate square root of 24 by guessing. Use a calculator to check your estimate. Okay. Well, I'm going to think of the 2 square roots in between there. 4 squared is 16. So the square root of 16 is 4. And 5 squared is 25. So this 20 square root of 25 is 5. And this is the square root of 24. It's going to be really close to the 5, but not reaching 5. So like 4.8, 4.89, something like that, maybe. 4.8 or 4.9 is what I'm thinking. It's going to be right in there somewhere. So let's check. The square root 24 equals, and that is 4.89. So basically 4.9. It's equivalent to. Not exact. All right. In the expression, square root of 9, and the symbol, the radicand. Oh, I've already done this one. Okay, cool. A right triangle. There we go. A triangle with one right angle is called a 90-degree angle, 90-degree triangle, or a right triangle. In the figure below, the right angle is marked with a little square. The side of the triangle that is directly across from that right angle is always called the hypotenuse. Hypotenuse. The sides of the triangle that include the right angle are called the legs of the triangle. Okay. The reason the hypotenuse is always directly across from the right angle is because the right angle is going to be the largest angle in the triangle. Since all of the angles add up to 180, this represents half of that 180. So the side directly across from it has to be the longest side. Okay. All right. The other thing is I'm going to let you know a theorem here in a second, and we're going to label this triangle with legs A and B, and these are interchangeable. We could have leg A here and leg B here. It doesn't matter. What matters is the hypotenuse is always going to be represented by the letter C. Keep that in mind as we move forwards with this next piece. The C represents the length of the hypotenuse of the right triangle. Let A and B represent the length of the legs. And again, it doesn't matter which one you label. This is the one that cannot be changed. The relationship between the hypotenuse and the legs is that if you take one leg and square it, and then you add the other leg squared, that is equal to the hypotenuse squared. Okay, and this is called the Pythagorean theorem. All right. So the legs of the right triangle, and they're giving us a problem here. So we've got a right triangle. I cannot usually draw, so bear with me. All right. So the legs of a right triangle measure 3 and 4 inches respectively. Find the length of the hypotenuse. Well, the hypotenuse is always directly across from the right angle. So this is my hypotenuse, which means I've got one leg that measures 3 inches and another leg that measures 4 inches. I could have put them in the opposite directions, but it doesn't matter. What matters is the C. So A squared plus B squared is equal to C squared. If A is 3 inches, we're going to square it. B is 4 inches. We're going to square that. It's going to equal C squared. Okay, 3 squared is 9. 4 squared is 16 is equal to C squared. I'm going to add these two, get 25 is equal to C squared. All right, to undo, or the opposite or inverse of a square, is a square root. So to get rid of a square, you have to take the square root. And because of this cute little equal sign, we have to take the square root of this side as well. So C is equal to the square root of 25, which is 5. So we're going to answer it as the hypotenuse is 5 inches. Okay. Given the following right triangle, find the length of the missing side. Okay, so this one, instead of solving for the hypotenuse, which is here, directly across, we're going to be solving for, we'll just call it b instead of x. A squared plus b squared is equal to c squared. If a is 5, x, we'll just call it b squared, is equal to 13 squared. 5 squared is 25. 13 squared is 169. Solving for b, I need to subtract 25 from both sides. And b squared is equal to 9 minus 5 is 4, 6 minus 2 is 4, and then 1. Okay, to undo a b squared, we have to take the square root. What do we do to one side because of this equal sign? We do to the other. Square root of 144 is equal to b, and that is 12. So the missing leg, the missing side is, there's no units here, 12. If there were units, which there should be, then you would give the units as well. Make sure you let me know what questions y'all have regarding these. Anything on here. All right. Given the following, given the following right triangle, find the exact length of the missing side and the approximate length. I'll explain that to you as soon as we get to it. So let's find the missing leg. I know that this is my C, and that's all I need to know. I can go a squared plus b squared is equal to c squared. Let's call this a this time. We'll call this b. So a squared plus 7 squared is equal to 12 squared. When it's cranking. A squared plus 49, 7 squared is 49, equals 12 squared is 144. And we're solving for a, so we're going to subtract 49 from both sides. We get a squared is equal to, what about the calculator? 144 minus 49, and that's 95. To get rid of the square, oh, yeah, we have to take the square root. And when we do that, a is equal to the square root of 95. Okay. Here's why I left it at that for just a moment. That is the exact answer. That is the exact length of the missing side. The reason you need to know the difference between exact and approximate is because in math, we expect the exact answers, and unless it has to do with a word problem. And then for science, they are usually okay with having the approximate. So I'm going to make sure you know how to do both. Bear with me just one moment. So when we take the square root of 95, that's going to give us an approximate answer, and I'll show you why. The square root of 95 is 9.74679435, and that keeps going. It keeps going. So and we want it to round to the nearest hundredth. So when we round something, we are no longer giving an exact answer. We are then giving an approximate answer. So our approximate answer, which is going to be our B, this is the answer for A, that is our exact answer. B, our approximate answer, rounded to the nearest hundredth. Let's see, that's 9.7. 4 is in the hundredths place. That's our rounding digit. 6 is our test digit. It's greater than 5, so I need to add 1 to that 4. So 9.75 is my approximate answer. Okay. The last one for this is Jenny wants to create a vegetable garden in the corner of her yard in the shape of a right triangle. She cuts 2 boards of length 8 feet, which will form the legs of her garden. Okay, so let's say that this is the corner of her garden, and these are both 8 feet. And then she wants to have a board. She cuts 2, find the length of a board she should cut to form the hypotenuse. of her garden. Correct to the nearest 10th of a foot. Okay. So a squared plus b squared is equal to c squared. We know that's c squared because it's directly across from her right angle. 8 squared plus 8 squared is c squared. 8 squared is 64. 8 squared is 64. 64 plus 64 is 128. The square root of 128 is 11.3137. But they want us to round to the 10th. So that's my rounding digit. That's my test digit. It is not 5 or greater. It is less than 5. So this is gone, and I'm going to have to cut a board this length. So the length of board should be about 11.3 feet. Rounding, sentence, unit. It's a word problem. That's what you have to represent. Next will be 29. So that is it for today. Let me know what questions you have.